The design deadline is tomorrow, and your client just changed the material spec. Again, thermal performance, construction complexity, budget constraints, sustainability certifications, juggling hundreds of variables in your head. And suddenly, it is well past midnight. Yet right now, there are architects completing this entire process in just a few minutes. Their tool of choice, an AI-powered material discovery system. Today we go deep into the era where data drives material decisions and explore exactly what that looks like on the ground. The material selection phase carries far more weight in a construction project than most people realize. Research consistently shows that materials account for roughly half of total construction costs on average, around 52%. Yet this critical decision still relies heavily on individual experience and intuition. The process tends to look something like this. Dig through supplier catalogs, request samples, ask a colleague, and repeat. The inefficiencies and misjudgments that accumulate from this approach quietly compound into project delays, costly defect remediation, and eroded client trust. This is precisely the gap AI is designed to close. By simultaneously processing tens of thousands of material records, global project case studies, and real-time pricing data to surface optimal candidates in ranked order. This is no longer a vision. It is already operational. What sets AI material discovery tools apart from conventional search? The difference lies in conditional reasoning, not simple lookup. Imagine a designer inputs the following: exterior cladding, thermal transmittance below 0.17 W per square meter K, fire rating Class A, budget under $90 per square meter, certified products preferred. A traditional workflow would require verifying each condition separately. An AI system cross-references all conditions simultaneously and ranks candidates by overall fit. It goes further still, surfacing which materials were actually used in comparable projects globally, and whether post-installation defect records exist. Platforms such as Autodesk Forma, Madaster, and Speckle are leading this space internationally, with BIM integrated material intelligence becoming a standard capability across major design platforms. Firms that have adopted AI-assisted design tools have reported approximately a 42% reduction in design error rates, a performance gain that flows directly through to material specification accuracy. So how do you actually integrate this into your workflow? Here are 4 practical steps you can begin implementing right now. The first is structuring your project conditions as data. Instead of keeping climate zone, occupancy type, budget, and certification requirements scattered across documents or stored in one person's memory, format them as structured, queryable data from the project outset. The second step is standardizing your AI prompts as a team. Develop a shared input template so that every material search query follows a consistent, comparable format, whether you are using a dedicated specification platform or a general-purpose tool like ChatGPT. The third step is cross-checking the AI shortlist. Validate AI recommended materials against your project specifications, internationally recognized certification registries, and live supplier inventory before committing. The fourth step is building the feedback loop. After construction is complete, record actual performance data against predicted specifications. Feed that back as input for your next material search. Each cycle compounds your team's specification accuracy. Teams that have established this kind of systematic process have reported approximately 38% fewer design change requests related to material specification. There is one more arena where AI material search proves especially powerful: embodied carbon and life cycle assessment, LCA. As building carbon regulations tighten worldwide, from the EU taxonomy and BREEAM requirements to LEED v5's expanded embodied carbon accountability, calculating a material's carbon footprint at the design stage is rapidly shifting from optional extra to non-negotiable requirement. Traditionally, a rigorous LCA calculation could take weeks of specialist work. AI-powered LCA platforms can now compare the carbon profiles of different material combinations in real time. when integrated with live pricing data. This allows design teams to simultaneously optimize for both carbon reduction and cost efficiency. A mid-sized construction firm that adopted AI-assisted LCA tooling reported approximately 22% lower embodied carbon at the design stage, alongside an approximately 11% reduction in total material costs, lower emissions and lower costs, achieved at the same time. Where does this technology go from here? Industry observers point to three trajectories that will define the next decade. The first is real-time supply chain integration. AI systems will continuously monitor global material availability, issuing early alerts when supply disruptions threaten specified materials and instantly proposing verified alternatives before those disruptions become delays on site. The second trajectory is digital twin convergence. As buildings become richer with connected material data throughout their lifetime, AI will predict degradation patterns post-occupancy and proactively signal optimal maintenance and replacement windows, turning material intelligence into a lifecycle asset, not just a design phase tool. The third is generative material design. Beyond selecting from existing product catalogs, AI will propose entirely new material formulations tailored to a project's specific performance envelope, then connect design teams directly with manufacturers capable of producing them. These are not distant scenarios. Several are already in active commercial pilot programs, with widespread adoption across major global construction markets expected within the next 3 to 5 years. As we have seen today, AI material discovery is not simply a convenience feature. It is a genuine competitive capability, one that raises the reliability of specification decisions, positions firms ahead of tightening global carbon regulations, and directly improves project profitability. Leading architecture and engineering firms worldwide are already embedding these tools into their core workflows, and the performance gap between those who have adopted them and those who have not is widening with every project cycle. Take a moment to consider, when was the last time your team selected a material based on structured data and verified performance records rather than experience and intuition alone?